a whole lot. So we'll see if I can do this on the fly. Let's see.
Oh my gosh, are we on video?
Yeah, you're getting recorded. So this is the block day lesson for Wednesday, Thursday, November 2 and 3.
Yeah, I'm not going to lie, Miss Wolf. I don't know why you chose our class for the video.
Yeah, I don't know. All right, so applications, meaning fancy word for word problems. And that's why you have provided notes, because it's a pain to write down, a long word problem. You spend all your time copying the problem down and rather than trying to figure out what's going on. So provided notes today because word problems take a while to write down. A calculator is required on these problems. So that means the test will have a part calculator and part no calculator. And if you need to grab a calculator, well, grab yours if you have one, but you're also welcome to grab one of my yellow ones out of the cabinet over there if you need to. I think the ones not in the container, their batteries don't work. The ones standing upright, those should be okay. Yeah, don't get the ones that are just sitting there. Get ones out of the wooden box over there. All right, we'll use 4 formulas for these problems. Here's the deal with these formulas. We will give you the formulas. Right, exactly. We'll give you the formulas, but they'll be given sort of at the top of the page. In fact, if you look at the next page, it'll look like that on the test.
Oh, I love this.
So you'll have them, but they don't tell you which problem they go with. They don't tell you what the letters mean. And so it's helpful to have them, but that's why we'll do the homework and the notes to make sure we know what the letters mean and when to use each one. All right. Some variables to go over before we even get to the formulas. A is the final amount or the ending amount. Sometimes I call it the after because after starts with A. So A is for after. Not technically, but that's how you remember which one it is. P is the principal, what you start with. So can you think of a word that means starting or before that starts with P?
Previous.
Oh, prior, previous, pre, all of those are good. I usually say pre, but those were good answers as well. So A for after, P for prior, previous, or pre, whatever you want to say. T is time, you're used to that. R is rate. You've done this before, just be careful because when you go from a percentage to a decimal, you got to move the decimal 2 spots. Right? So let's practice one of those. What's 3.5%? 0.035. Okay. Good. So be careful with the percentages in there. For one of the formulas, we also have an N in the formula. This represents the number of times per year that an investment is compounded. So that's a lot of words, but compounded monthly, that means 12 times per year. Compounded yearly, that means N equals 1. Compounded quarterly, how many quarters are there in a year? 4, because there's 4 quarters in $1 and 4 quarters in a football game, and 4 quarters in a year. What about daily? 365. 365 and a fourth if you want to be technically accurate. Here's our 4 formulas. Compound interest formula. You may have seen this one before. The after equals the pre times something. So you start with a P, you multiply it by something, and your after is hopefully more than you started with, right? If you're investing wisely. The continuous interest formula, it's kind of the same. It has the same P and the same A, but if you're continuously compounded, the E shows up, and that E is the 2.718, but it's also in the calculator. So you use the calculator E, not rounded E. Kind of like pi. Don't round it. Use the E that's in the calculator. All other principal rate amount problems, you'll use this formula. And they'll usually say something like growth or decay. And so you don't use the plus and the minus. You pick the one that fits the problem. And so you just have to read the population grows, or the value declines, or the population declines. So you just got to read the problem, and if it's growing, then use the plus. If something's shrinking, use the minus. And lastly, the half-life formula. This one is tricky because students get the T and the H confused. The T is the variable. That's what's changing. That's time. H is a constant. And it's called the half-life constant. It's how long something takes to decay by half. So they will tell you what the half-life is. Maybe it's 1,000 years. So in 1,000 years, it's decayed by a half. All right, let's try some examples here. $5,000 is invested in an account which pays 3% interest compounded monthly. What is the value of the account in 10 years? So there's 4 formulas to choose from. How do I know which formula I should use? To me, there's a dead giveaway in this problem as to which formula we should use. Compounded monthly means we will use the compound interest formula, but not compounded continuously. If it wanted you to compound continuously, it would use the word continuously, like number 2, compound continuously. So compounded monthly, and then monthly means N is 12, so 12 times a year. What is the value of the account in 10 years? So what's it asking for? The A. It's asking for the after. In 10 years, find A. Find A. Let's see if we can figure out what all the other numbers represent. $5,000 is invested. So what's $5,000? The P, the principal, the previous, the prior, whatever you want to call it. What's this 3%? The rate, sort of. Right, what are we going to plug in for 0.03? And in 10 years, that's the time. T is 10. So the after is $5,000 times 1 plus 0.03 over 12 to the 12 times 10. And that's why you have a calculator. So grab a calculator, make sure you can type it in. Right? That's why we take time to do this, so that on test day you don't say, where's this button? How do I make this happen? Like, no, that's why we do it now. 5,000 times parentheses 1 plus. Some people are going to use the fraction bar. Some people don't like the fraction bar. I don't think it's really necessary when you're just doing 0.03 divided by 12. It's more important when there's like the fraction's kind of crazy and you need to be careful. All to the 12 times 10. So make sure your calculator can get you to $6,746.77. Always round it to the hundredths with money, because that's your nearest penny. And one of the maybe few nice things about word problems is you can kind of have a reality check on them. Like, you guys aren't bankers. You probably don't have a good feel for, if 3% in 10 years, how much do I have? But you should have more than 5,000, right? You shouldn't have any negative money. It shouldn't be less than 5,000. If you got, 14 million for an answer, hopefully you think, wait a minute, that doesn't seem right that I could invest $5,000 and 10 years from now have 14 million. Like, that seems a little bit sketchy. So investing in some unusual.
That's what you call a pyramid scheme.
Yeah, something's going on there. So you can't tell for sure that your answer is right, but with word problems, you should be able to tell that it seems, that seems like a reasonable answer. Number 2, how much money was invested at 2.45% compounded continuously? So that means we need the continuously compounded formula. Okay, what's it asking me for? Okay, this one's reverse. How much money was invested? So we're finding P. And A, the after, is 2,000. So 2,000 equals P. E to the R, be careful, 0.0245. 9 years later, times 9. So what should I do to get P by itself? Divide. So, and I got a calculator, so yes, this is going to look kind of ugly, but 2,000 divided by e to the 0.0245 times 9. That one might be a good one to use the fraction bar on. And the fraction bar is alpha y equals, or alpha f1. If you like the fraction bar, it makes it easy to see, who's in the top, who's in the bottom. There's 2 E buttons. One on the left has the built-in exponent, since most of the time E has an exponent. So that's usually the one we use. There's one on the right above the division sign that's just the letter, or the number E. You can use either one, but the one with the built-in exponent is probably the preferred one, because that's the one that saves you a little bit of time. 2,000 divided by e to the 0.0245 times 9. So I got the pre to be 1604.24.
You also just do 2,000 divided and then parentheses e to the.
For sure. Just be careful when you're dividing. Make sure you're dividing by the right stuff. That's why the fraction bar is sometimes easier to see what's going on. Uh-oh. What did I? Oh, I put the wrong thing in there. 0.0245. There we go. That's the same now. So, fraction bar if you like. You don't have to. Just be careful either way. Do you know where to find the fraction bar? Okay. Number 3. How much time will it take? So find time this time. For a $3,000 investment to double if it compounds every 6 months. So I know which formula I'm using because of that every 6 month thing. Again, you don't have to have them memorized, but you better be able to recognize them and know when to use which one. At a rate of 8.5%. Okay, so what's the 3,000? That's the P, so we're starting with 3,000. 1 plus 0.085 over n. What's n? Oh, we didn't talk about this one. but the end would be 2. It's how many times per year. So every 6 months would be twice a year. They didn't tell us the after.
Wait, don't you know 6,000?
They didn't directly tell us the after. They wanted you to read carefully. If it doubles, then it's 6,000. Okay, this one's a little bit harder. This one's not a direct, enter it in the calculator. I've got to do a little bit of work with my math, my algebra skills, then I go to the calculator. So I'm trying to get t by itself. What should we do first? Let's divide by 3,000, then we'll log it. So dividing by 3,000 is great because that just gets us back to 2. Some people are going to put this in the calculator and then carry all of those decimals, which would be fine. I'm just going to keep writing it as this. All right, now what would you like to do? Yeah, now let's log both sides. Yuck, why would we do that? Why would we do that? What benefit does that get us? Yeah, it gets the exponent down. So natural log 2 equals natural log of all of this mess. Pardon? You could, if you wanted to type that in and then use that decimal, that's fine. I'm just saving it for the end. I'm out of space, but I know the reason we logged it is to get that 2t down front. Okay, so I'm getting close. There's t. Algebra experts, what should I do to get t by itself? Divide by. Now I want to leave the t, so don't divide by 2t. Divide by all the other stuff. You want the t to stay, so let's divide by the 2 and the natural log of all of that stuff, which Braden would have already found a decimal for. Which is fine. I'm not making fun. That's a different way to do it. That's a lot to keep up with, but I'm left with just t. This is one where I would definitely use the fraction bar, because otherwise your parentheses are going to get kind of crazy. You can do it without it, but it just seems like it'd be a whole lot easier to alpha y equals. Again, that makes it just real easy to see who's in the top, who's in the bottom. 1 plus. You can even go fraction bars inside fraction bars if you want to go crazy with it. I probably wouldn't do that, but if you really like your fraction bars, natural log 2 divided by 2 natural log. Ugh.
Wait, how do you get the fraction bar?
Alpha y equals the F1 menu, and the first one is n over d, numerator over denominator. This is another one where let's see if this answer makes sense. Again, you're probably not familiar enough with money to know if that answer makes sense, but for money to double in 8 years, that seems reasonable. It's not a gazillion years, but it's also not 3 days.
How do you get rid of the, like when you type in 2ln, how do you get rid of the parentheses? Oh, anyway, I see.
Well, when you hit ln, it opens a parentheses because you need a parentheses. You have to close it. So when you hit natural log, it opens one. I don't even think you can get rid of it because you've got to have it. You just got to make sure you close it in the right spot. Over on the left. So the answer was 8.3 years. Let's do one more, and then I'll post two separate videos, part 1, part 2, and you guys will just need to watch part 2. Everybody else will have to watch both. So number 4, at what rate, so already we know what we're looking for, at what rate does an investment of $4,000 triple, so $12,000, in 10 years, compounded continuously? Continuously being the magic word to tell me which formula to use. So $12,000 equals $4,000 e to the r times 10. What do you want to do first? Divide by 4,000. Which means we really didn't even need to tell you how much it started with. This is the next level stuff here. I could have just said, how long does it take to triple? And it wouldn't matter if you started with $1 and landed at 3, or 4,000 and landed at 12,000. The first step you do would be to get a 3 over there. All right, what next?
Log it.
Log it to get the variable out of the exponent. So natural log 3 equals 10r. Natural log e if you want to write it, but natural log of e is 1. And then this turned into kind of an easy problem. Natural log of 3 divided by 10. Be careful. Watch what I'm writing in the calculator. Whoops. Natural log of 3 divided by 10. Is that going to be the right answer?
No.
No, because it's going to be the natural log of 3, close parentheses, divided by 10.
What do you round to 1,000?
3 decimals usually. Ooh, that one's going to be tricky though. So if I want to put it as a percent, it would be 11.0%. That's a very good interest rate, but you tripled your money in 10 years. You would need a pretty good interest rate to triple your money in 10 years. Again, the more of these you do, the more you'll get a feel for it.
What's the interest rate right now? Like 60?
So if you're just watching the video, you need to. This one's going to end, and then you'll watch the second video where I watch the rest.